For each sequence below, determine the next term and then write an explicit equation to represent the sequence. So this is the same as what problem C up above was. So we're adding 0.5 each time. So the next term is going to be 3.7. All right. Now, if we want to write an expression, remember an arithmetic is just y equals mx plus b, right? You have the beginning term, which is the 0 term, plus mx, right? Y equals mx plus b. So let's think about this. The beginning term, this is the first term, so I need to know the 0 term. The 0 term would be if I subtracted 0.5, so it would have been 0.7. So that's my b value. And then what am I adding each time? I'm adding a 0.5. And that is my explicit term, or my explicit equation for an arithmetic sequence, right? I have the 0 term plus whatever you're adding each time. Okay. Now here, this is the same as what we saw in problem A up above. So we are multiplying by a negative 1/2 each time. Okay. So my formula here is I take the first term and I multiply it by the common ratio to the n minus 1 power. All right, if I plugged in 1, this would be, the value of this would be 14. If I plugged in 2, the second term would be 14 times negative 1/2, which is negative 7. If I put in 3, this would be negative 1/2 squared, which is going to be 1/4. 14 times 1/4 is 3.5. Okay, so that works. Or we could have figured out what the 0 term would have been, which would have been negative 28, and then multiplied that by 1/2 to the n power. I don't think anybody came up with this expression. This one works. It's always the first term times the common ratio to the n minus 1 power. Always. For a geometric sequence.